Hello class, this is section 1.2, types of data. I am your instructor, William Buhlman, and this is Stat 1200. So first we have some objectives. So the objectives for this section are to be able to understand the structure of a typical data set, distinguish between qualitative and quantitative variables, distinguish between ordinal and nominal variables, and to distinguish between discrete and continuous variables. So first we have to go through a couple of definitions. So for the first one, the values of the variables that we obtain are the data. The characteristics of the individuals about which we collect information are called variables. The information collected is called a data set. So here we have qualitative versus quantitative variables. So qualitative variables classify individuals into categories. So you could think of this just how you think of any category. So maybe someone is tall or short, skinny or not skinny, different categories like that. There's not a numerical value attached to it. Either you're a student or you're not a student. Next, we have quantitative variables. So these tell how much or how many of something there is. All right, so now we're going to go over a couple of examples. All right, so here's our first example. So a person's hair color. So we have to ask ourselves, does this tell us how many of something there is, or is this a category? Well, let's see. Hair colors are like blonde, black, brunette, red, colors like that, green, blue. So there's all sorts of colors, but that's not telling me how many. So since it's not telling me how many and it's a category, we're going to have to say this is a qualitative variable. So next we think about a person's weight. Okay, when you talk about somebody's weight, it's 100 pounds, 200 pounds, 150 pounds, 250 pounds. So we're getting a number. How many? Those aren't categories. So since it's a number and not a category, it's a quantitative variable. Okay, next we have a person's sex. Okay, if we think about sex, it's either male or female. Well, that's not a number, that's a category. Either you're male or female. So this would be qualitative because it's categorical. And then finally, a person's salary. So salary is how much money somebody makes. So again, 20,000, 40,000, 50,000, 60,000, whatever it is. So that sounds like a number. So since it is a number, we're going to have to say it's quantitative. So here we're going to have some practice for you guys. So right here, you're going to want to pause the video, fill in each one of these as qualitative or quantitative, and then come back and check the answer. So the answers will be starting in 3, 2, 1. So the first one, your best friend's name. So your best friend's name, is there a number attached to it? Probably not. So we're going to have to say that is a qualitative variable. The title of a statistics book. Again, is there a number attached to that? No. So it's going to again be a qualitative variable. The number of files on a computer. Well, numbers right there, so it's an amount of something, so that must be a quantitative variable then. The waist size of a pair of jeans. Okay, well, when we think about sizes, they're numbers, right? For females, zeros, ones, twos, threes, etc. For males, 28, 30, 32, 34, there's sizes in between. So it's a number, typically. So we're going to have to say that is quantitative. And the makes of cars sold by a particular car dealer. So when we think of a make, right, we think of like Chevy, Ford, stuff like that. Those aren't numbers, so that must be a qualitative variable. So now we're going to go into our next set of definitions, ordinal and nominal variables. Ordinal variables have a natural order. A nominal variable doesn't have a natural order. Second example. So now we're going to have to identify each of these as either ordinal or nominal. So the size of a Starbucks coffee. So we think about it, sizes. They come in small, medium, large, extra large. Do those have an order? Well, a small is smaller than a medium is smaller than a large is smaller than an extra large. So there is a natural way we can order these that makes sense. So since there's a natural order, this is ordinal. So letter grade in your class. We have A's, B's, C's, D's, F's, and all sorts of pluses and minuses. And if we think about it, is an A better than a B? Is a B better than a C? Yes. So there is an order here. So again, it is ordinal. So the city that a person lives in. We can think of San Francisco, New York, Los Angeles, Miami, Las Vegas, all these things. But is there a particular order that matters? No. If I put San Francisco before New York, it doesn't matter. So these are nominal. A person's sex. So again, we have male and female. Does it matter if I put male before female or female before male? No. There is not a natural order. So we have nominal again. All right, so here's another example for you to practice. So you're going to identify each one of these as ordinal or nominal. So again, you're going to pause the video here, answer the questions. The answers are going to be starting in 3, 2, 1. So if we think about it, the categories: strongly disagree, disagree, neutral, agree, and strongly agree. Is there an order to that? And yes, there is, right? If we think about it, if you disagree or you strongly disagree, there's a difference. If you strongly disagree, you have more feelings on that disagree than a normal disagree or a neutral. So there is an order here. So this is ordinal. I got an A in statistics, B in biology, and a C in history and English. So if we think about it, we go, okay, is there an order here? Well, I'm talking about the grade I got, not the class, the grade. So is an A better than a B, better than a C? Yes, so it is ordinal. Now, if I were to flip this and say, in statistics, I got an A. In biology, I got a B. In history, I got a C. In English, I got a C. That would be nominal, not ordinal, because now the variable of interest is not the letter grade, but the class I'm taking. So we have to be very careful to understand what our variable of interest is. So now number 3, I ordered a pizza with pepperoni, mushrooms, olives, and onions. Okay, if I would have said I ordered a pizza with olives, mushrooms, pepperoni, and onions, does it matter? No. So the order in which I list the toppings does not matter. So this is nominal. Number 4, I finished first in the high jump and third in the pole vault. So again, we have to think about, what am I talking about here? What is my variable of interest? Is it my placing or the sport? Well, it is the placing, because I'm talking about I got first in the high jump, in the high jump I got first. So since we are saying we're talking about our placing first and not the sport, that is our variable of interest. So if I compare first and third, is there a natural order? Well, yes, first is better than third. So this is ordinal. So last one, the names of counties in a state. So if we think about it, in California, we have San Bernardino County, Los Angeles County, Orange County, Riverside, San Diego, all these different counties. Does it matter the order in which I list them? No. There isn't a natural order just instinctively. There is no natural order, so this is nominal. All right, so we're on to our last set of things, discrete and continuous variables. For discrete variables, possible values can be listed. So for this, you could think of like the number of chairs in a classroom. You can count it, 30, 27, 28. It's a whole number. It's something that can be listed. Continuous variables can take on any value in some interval. So if we think of the real number line, it has whole numbers, 1, 2, 3, 4. It has negative numbers, negative 1, 2, 3, 4. There's fractions in there. There's square roots in there. There's decimals. There's all these different values in the real number line. So that can take on any value. So that's a continuous variable. All right, so we're on to example 3 here. So identify each of the following as discrete or continuous. So first, a person's weight. So let's say we weighed somebody and they weighed 150 pounds. And then I got a better scale that said, no, they weigh 150.1 pounds. And then I get an even more accurate scale that says, no, they weigh 150.12 pounds. So we can see as the scale gets better and is more refined, we can get a better measurement. So since this can take on any value, it just depends on how accurate our scale is, this is continuous. Okay, so let's think about the number of desks in a classroom. If I count it and there's 28 desks, there's no instrument that can make it more accurate than 28 desks. You can't have a half a desk. Either you have 28 or you have 29. So since there is no possible values between 28 and 29 for the number of desks, this is discrete. Okay, the number of classes a student is taking this semester, right? So if we think of how many classes a student is taking, it's either going to be 1, 2, 3, 4, 5, however many they're taking. But it's a whole number again, like the number of desks. You can't take 3.5 classes, right? You're either taking 3 classes or you're taking 4 classes. So this is, again, discrete. The distance somebody commutes to work. So you leave your house, you get in your car, you go to work. Maybe it says it's 3 miles. Okay, but then you look it up on your phone and you see, oh no, it's 3.1 miles. And then you get some other instrument and you measure it and you figure out, no, it's 3.12 miles. Again, it depends on how accurate your instrument is for measuring. So since there are values between 3 miles and 4 miles, depending on how accurate your instrument is, that tells you these are continuous. Okay, again, we have a practice now. So this is example 3 practice. So what you're gonna do here is you're gonna pause the video again as normal, decide whether each of these are discrete or continuous, and then come back and listen to the answers. Okay, so the answers are starting in 3, 2, 1. First one, the amount of caffeine in a cup of Starbucks coffee. So again, can I get a way to measure this more and more accurately? Well, yes, depending on my instrument, however I measure caffeine, I can get a more accurate number. So this is continuous. The distance from a student's home to his school. Okay, distance, right? Okay, we talked about this before. If we're in a car, depending on how Google Maps maybe does it, or if we were to measure it with the tape measure, depending on how I measure it, I will get different numbers, and they are all different accuracies. So again, this is continuous. The number of students enrolled at a college. Okay, well, when I think about students, is there an in between 30,000 and 30,001 students? No, either you have 30,000 or you have 30,001 students. You don't have 30,000 and a half students. So this is discrete. The amount of charge left in the battery of your cell phone. So if you think about it, your cell phone, or in this case, my iPad shows that I have 46% charge left. Is it exactly 46? No, it's just what it's showing me. If we were to be able to measure this more accurately, it might only be 45.9. And then if it was even more accurate, 45.87. We don't know. It just shows a whole number, but we could measure it more accurately, so this is continuous. Okay, the final one, the number of patients who reported a new drug relieved their pain. So if you think about it, okay, so if patients are trying this new drug, whatever it is, to help with their pain, either it helped or it didn't, right? So either somebody it helped them or it didn't. So let's think about that. Is it possible for somebody to be halfway? Oh, it helped, but it didn't. No. Right? You're either going to have 15 people that it helped or 16 people that it helped. You can't have half a person that, oh, it halfway helped me. No. Either it helped you or it didn't. So since it is that way, it is discrete. So now, just as a final recap, you should understand the structure of a typical data set, be able to distinguish between qualitative and quantitative variables, distinguish between ordinal and nominal variables, and be able to distinguish between discrete and continuous variables.